Our next talk is going to focus on cross-chain apps powered by real-time proving. And get excited, we're going to see another demo. We love to see a good demo because it shows us exactly how things work. In this talk, we will dive into xYield, a cross-chain vault optimizer built on T1's real-time proving based on cross-chain application infrastructure. xYield enables yield optimization in the multi-chain world by automating deposits, withdrawals, and bridging across yield sources on multiple chains based on verifiable strategies proven on-chain by Ts. So that was a mouthful. I'm sure that it will make a lot more sense, at least for me, once we see the demo. We solve interop challenges by eliminating the need to switch networks and bridge funds, because at the end of the day, things have to be easy for things to be usable, and not just if we want more adoption, but for ourselves as well. Please welcome to the stage, Orest.
Thank you so much. Hi guys, welcome, and thank you so much for staying to this late hour. I appreciate that very much. I know it's been a long day, and it's super cool to see so many of you actually care about not just interoperability and the interop landscape, but also the prefix of this event, which not for no reason is called trustless. We have the trustless manifesto over here, and I'm very glad that we've just heard a talk by Stephen from Offchain talking about how interoperability should actually be reflected in the wallet, because I can call out a couple of elements in that approach that are not exactly trustless. Like we can talk about RPCs, but we can also talk about proving and following the different chains. But then again, there's also the user experience element, and this is something I would like to focus on the most today. So what I would like to present to you today is a very quick recap of my rough thinking about creating interoperability in a world where there is 15B on Arbitrum and 15B on Base and other rollups that are incumbents and that have the staying power, etc. So I would like to give you a recap of how to create interoperability without changing them. I think we align with the previous speaker on that. But I also like to show you how creating programmability in this paradigm unlocks new use cases. And by programmability, I mean not having to actually go ahead and click a button in your wallet every day. And finally, I would like to show you a demo of an app that is made possible by infrastructure of this sort. Okay, so what's crypto like today? I guess it's obvious to anyone here, we have a lot of islands that have pretty good intra-cluster, same island interoperability, like the aforementioned rollup clusters. And one could state, well, there's all those intent bridges, and if I want to have 5 ETH or $1,000 from Arbitrum on Base, I can easily bridge. However, I would argue that this is not what interoperability is about. I would say that interoperability is about composability, not just bridging. And composability is the idea that you can actually have this program that does the swap on Arbitrum against your ETH, gets you USDC, and then you could have another program on Scroll that consumes the output of the other Arbitrum-based program to do something yet again, and its output can be used by yet another rollups, dApp, and so forth. So basically the idea of the original Linux CLI vision with one tool to do one highly specialized job, and that job alone, but combined in a paradigm where it's very easy to just pipe the output of this highly specialized piece of software into the input of this other specialized piece of software. And that without those individual constituents having awareness of each other, without them necessarily having been programmed to be aware of how the inputs and outputs could be composed. And so if you combine programmability with real-time proving, I would argue only then is it that we get to real composability, to real trustless interoperability, and this longed-for user experience of a click-and-forget user journey. Now, in terms of numbers, status quo is we have optimistic rollups with multi-day delays to finalize on DL1, and we have ZK rollups with maybe an hour of a delay to finalize on DL1. And technically, you could argue we have composability already. It just happens to be super slow, and in fact, it's as slow as though to prevent anyone from practically leaning on that paradigm. You don't see applications where you do something on Arbitrum, use the canonical bridge to go via DL1 and then deposit that maybe output into scroll and do something on scroll. So yeah, that doesn't happen. Now, with an infrastructure like T1s, what you can do is you can take a network of security-hardened TEEs, run follower nodes for all of those existing rollups sequences that are actually consuming the state as it gets produced and exposing the ability to read that state from any other rollup or from the T1 native block space. Now, with this, you already get certain benefits, such as the ability to quickly prove intent fills and therefore provide better quotes. But what's really interesting is enhancing this infrastructure with the ability for such a cross-chain dApp to request a read happen in one of the incumbent rollups. So what you can do then is you can react to a state change in Arbitrum. You can maybe withdraw your position from a vault on Arbitrum, and you can instantaneously bridge the output tokens and open another position on base. And all of that would be done with this read and write capability. It is a best effort base, but a very versatile one within the hardened TE infrastructure. So basically, in developer terms, what you can think about as a parallel is the asynchronous programming paradigm with callbacks, where you may, as a developer, request that some transaction be put on base, and at some point in the future will hopefully the success callback be called, to which you can then react in your application logic, or a timeout will hit because there is no guarantee that the success will ever happen, and then you can revert, and unfortunately you must indeed revert the previous legs of your meta transaction, of your super transaction, to restore a consistent state. Now, this is what in our thesis hopefully is the best we can get to in the world as it is today with the incumbent rollups, to approximate the original vision of the money building blocks that DeFi was enabled by in the first place, but in this cross-chain interoperability compatible paradigm. The team behind this is my co-founder, John, who previously co-founded Secret Network, using TEs also for privacy, and learned his lessons there. This is one of the ingredients for the design we've been working on, because we learned the lesson of securing TEs and identified how much easier it is to actually be able to just reproduce computation within a TE and then have attributability in offenses that the TE might have committed versus leaking secrets, which is not attributable. And then there's me. I previously co-founded 2 non-crypto startups and then worked at Scroll. Again, learning about the limits of practical ZK applications, learning about the strengths, but also the weaknesses of a ZK-only system, hopefully distilling the lessons and hopefully putting them to good use. Now, we are talking about cross-chain applications. We are here to go from the user perspective, and why does any of that protocol design stuff matter in the first place? Well, it matters because in a paradigm with interoperability being easily available, the user experience actually improves significantly. And the user experience can indeed even be quantified in terms of financial gains or savings as relevant in DeFi applications. So one example I'd like to guide you through today is what I call Yield. We literally just came up with this name this morning, so I hope no one will front run us to the domain. The idea is, how about instead of the user journey that the previous speaker just described, where the wallet does things for you, how about you express the idea of not caring which Euler deployment you want to put your funds to in terms of chain. You don't care if the Euler vault is on Base or Arbitrum or Scroll, but you care that it's the Euler vault such and such with the risk profile such and such. So how about you express that desire and then let a security-hardened TE network run this application, run this program that tries and materializes your desire using the ability to talk to sequencers of the chains involved. And so what it would do is it would check, okay, what's the yield on Euler Base, what's the yield on Euler Arbitrum, and it would go and bridge as necessary and open a position on the user's behalf. The idea being that this yield, this APY, could change every day, and so the this sort of agent running in this TEE-secured programmable paradigm could be checking APYs continuously, and it could even be running way more complex trading strategies. So if the demo gods are with us today, great, we will be able to see a live demo of this, but to give you a quick gut feel on why we care, we ran a couple of, we crunched a couple of numbers, and we found out that even at a very short term, a couple of bridges involved potentially, we are able to generate a yield which is up to 30% higher in a world where bridging between the different instantiations of a given USDC vault is possible versus just staying on one chain. So this is the money that you are basically forgoing by not continuously opening your wallet and moving funds manually. Whoa. Okay, so let's see if demo gods are with us, and we will be trying. We will be trying to do the thing that the TE is supposed to be doing automatically for you live. So let's see if the Wi-Fi is with us. It seems so. So what you can see here is the interface of Yield. The interface basically talks to a backend which is hosted in a hardened TE. And we can see, okay, there's this Euler Gauntlet USDC vault. Let's go ahead and fire it up. And whoops. And so we see, okay, we have a total deposit number of 140 bucks. Let's connect my wallet. A couple of days ago, I deposited some money. I deposited something over 100 bucks, and I can see, okay, cool, my position is worth 126 USDC currently. I accrued some yield, like this is the total yield accrued. And interestingly, I can also see the rebalance history. So you can see, okay, November 6th, 2 weeks ago, Arbitrum was the chain on which the yield was highest. And so from November 6th to November 17th, did the TEE agent keep user funds in that deployment, getting an average APY of a stunning 9.5%. But then the market moved, whatever, and on November 17th, the agent decided to move funds from Arbitrum to Base, and it remains the most attractive vault deployment to this day. And we can confirm that by going to Euler scan, and we see, okay, the Arbitrum volt is at 3.6%, and the base volt is at 8.7%. This looks right. So how about we do the hard thing? Let's assume a user Alice is on the chain that does not have the high yield. So in this case, let's assume she's on Arbitrum, where the high yield is on base. And let's see what the UX of T1 enabled infra looks like. Let us try and deposit $40 into this cross-chain vault. And you can see there's no permit required. We will be sending $40 to an EOA that was generated and is managed by this dedicated TEE. Let's do that. And we can see then on Arbitrum, let's open Alice's account. This is Alice's account on Arbitrum. And we can see token transfers. 10 seconds ago, Alice moved $40 out of her account to this dedicated EOA run by the TEE. Let's open that account and see what's going on there. We see 25 seconds ago, Alice deposited into this dedicated account, and a couple of seconds later, the agent decided, hey, I actually want to bridge over to the other network. In this case, it decided to go with across, and it sent $40 to the other network. So let's see what's going on here in our front end, if our deposit arrived. And there we go. We can see, okay, we have $166 total deposit value. It is accruing interest on base, and should the market conditions change, will the TE agent automatically move the money to yet another chain and ape into yet another vault to earn yield. That was the demo. Now, how is this even safe? How is this even secure, you could ask? We've heard about all those TE exploit and TDX fail and TE fail and whatnot. And I keep saying security hardened TEs. I keep saying that for a reason, because again, we all learned our lessons, and TEs can only be trusted with certain things and should not be trusted with others. In our situation, there will be significant funds secured by the TEE. So it's important to take precautions against untrusted node operators, etc. And so what we elected to go with is a tiered security architecture that I call defense in depth, which starts with fast and efficient TEE proofs that are running computation, TEEs that are running computation and creating proofs that are verified on-chain. And then in the next step, will we be adding multiple TEEs coming to consensus about this compute, so that they need to basically vote on the output of the program after it ran and reach consensus there, possibly and optionally secured by restaked stake. But then you could ask, what if there's like billions of dollars being secured by the system? How can you ever reach this level of stake? And the answer here is we have the idea of keeping track of what the value that is being secured by this consensus of TEEs amounts to. And as it approaches the crypto economic security limits of the system, would we encourage the creation of an ad hoc zero-knowledge proof of all the state transitions up until now? And with this, should this ZKP be able to be verified on-chain, would the system be able to securely reset the value at risk counter and therefore continue operating with low latency and then finalize on-chain without issues? And then in the extreme scenario where a single transaction or like a very small amount of transactions were to exhaust the crypto economic security budget instantly, would we need to actually hold finalizing and require a zero-knowledge proof to continue finalization on-chain? And so overall, we have a couple of more ideas around creating censorship resistance in the system on top of this. Not everyone will be able to easily get a hold of a TEE. Not everyone will be able to actually run several rollups follower nodes. This is quite quite beefy hardware that you need, etc. And so to create censorship resistance, we are also introducing in our long-term vision an additional role that I call the sequencing AVS, the sequencing actively validated service here, which only is tasked with ordering user transactions, like things such as the MetaMask transaction that I just showed you, into bundles, signing off on those bundles, and only then passing them over to the execution AVS, which is running inside the TEE, which is able to decrypt those transaction bundles and only then execute them, and which is then actually running the state transition and the new state root submission on chain. But they do not have the ability to reorder user transactions or to exclude users, censor users. This, we hope, will create a system which hits a good balance between latency and censorship resistance in this case. Finally, quick roadmap to mainnet. Like, this is infra, so of course things take time, but we elect to take an approach that's quite lean, and we start with a very lean version of our mainnet, which we just announced a couple of days ago, on which xYield is running already. Like, you can, what we've seen before was real funds on Arbiter mainnet and base mainnet using real USDC. This is live already. Next up, will we be securing this network and adding permissionless block space in which any application may be able to benefit from the ability to interact with other rollups. And finally, will we be opening up the network towards a decentralized architecture. And so my call to action for you today is, if you are interested in taking xYield for a spin, please hit us up. This is a link to a very short form where we will be selectively inviting people who want to risk their funds on mainnet in exchange for maybe high yield. So far it's been significantly higher than staying naively on one chain, and definitely a lot of satisfaction of finding out how a post-interop, post-fragmented Ethereum world might look like. So please hit me up if you have any questions, and if we have time for questions, I would love to take some. Do we have time? Okay, so thank you very much, guys.
Thank you for the wonderful